Okay, so this is our SR flip-flop, and let's see how this works. See, this is Q and this is Q bar, meaning Q bar is going to be opposite to Q. So when Q is 1, Q bar is going to be 0, and when Q is 0, Q bar is going to be 1, right? So these are the opposites of one another. Okay, let's get started. Let's take a look at this table that we have, and let's see how we are going to we're going to solve this, right? So let's assume the initial state is of Q is 1. This is the initial state of Q, and the initial state of Q bar is 0, and the input S that is being provided is 0, and the input R that is being provided is 0. Okay, so let's see how this works. See, this output from here is being fed back, right? So at the beginning we have a 1 here, right? So this 1 is being fed back here, and S is equal to 0, whereas this input is equal to 1. When we give a 0 and 1 to a NOR gate, let me quickly draw the truth table for a NOR gate. The truth table for a NOR gate. A, B as inputs and C as output. 0, 0, 0, 1, 1, 0, 1, 1. So the output is 1, 0, 0, right? So that's the output. So when we give 1 and 0 as input, 1 and 0 as input to this NOR gate, then 1, 0 is going to give us a 0 at the output. So previously we had a 0, and even this time we have a 0. So this 0 is going to be fed back to this gate, right? So we have a 0 here. R is already equal to 0. This input is also 0. So when we have 0, 0 here, we get 1 at the output. So we're going to get a 1 here. Previously we had what? Previously also we had 1. This time also we have 1. So this means that this state is final. Previously we had 1, now we have 1. Previously we had 0, and this time we had 0. So this is the final state of Q and Q bar. So Q is going to be 1 and Q bar is going to be 0. So this is the final state of Q and Q bar. Okay, let's try this scenario. In this scenario, initial state of Q is 1. So the initial state of Q is 1 and initial state of Q bar is 0, and R is equal to 0 is being input here. So R is 0, and S equals 1 is being input here. So S is equal to 1. Let's get started. See, the initial state is 1. So this 1 is going to be fed back here. So now we are going to have 1 here, and then S is also 1. So when 1 1 is input to a NOR gate, when 1 1 is input to a NOR gate, we get 0 at the output. Now previously we had 0, even now we have 0. This 0 is going to be fed back to this NOR gate. So this time R is 0 and the other input is also 0. When 0 0 is input to a NOR gate, the output is 1. So previously we had 1 at the output, even now we have 1. So the state of Q has not changed. We don't need to feed it back once again, right? So this is the final state of Q, which is going to be 1, and the final state of Q bar is going to be 0 in this case. Okay, let's do the next one now. The initial state of Q is 1 and Q bar is 0, and the input S is 0. So S is 0 and R is 1. Okay, I forgot to put the, so Q was 1, right, and Q bar was 0. Okay, so now what's going to happen? See, this is going to be fed back, right? This goes back, and now we have 1 here. So when we feed 1 and 0, 1 and 0 at the input will give 0 at the output. So this will give a 0 at the output. Previously we had a 0, even now we are getting a 0 here. This 0 is going to be fed back here. So now we have 1 and 0 at the input. When we have 1 and 0 at the input, we are going to get a 0 at the output. So this time we are getting a 0 at the output. Previously we had a 1. So the state of Q has changed. this new state of Q needs to be fed back. So now we're going to feed back this new state of Q. So we're going to feed this back, this new state, and this is going to be what? This is going to be 0. So when we give 0 0 at the input, right, 0 0 at the input, we'll get a 1 at the output. So this time we are getting a 1. Previously we had a 0, but now we are getting a 1. So the state of Q has changed, right? So this one, because this is a new state, needs to be fed back. So we're going to feed this back, and now we get what? Now we get a 1 here, right? So when 1 1 is fed to the NOR gate, the output is 0. This time the new output is 0. So the new output is the same as the old state of Q, right? Previously it was 0, and even now the new output is 0. So because the state of Q is unchanged, we don't need to feed it back. So we don't need to feed it back. This is the final state of Q, and now this would be the final state of Q bar. So the final state of Q is 0, and the final state of Q bar is 1. So let's go to the next state. Okay, this time we have Q as 0 and Q bar as 1. So Q is 0, Q bar is 1, and S is 0. So S is 0, and R is also 0. So R is also 0. Let's see what happens. Okay, so this output 0 is going to be fed back, right? So we're going to have 0 0 as the input to this NOR gate, which will give us 1 as the output. So previously we had 1, even this time we have 1. This 1 is going to be fed back to this NOR gate. So now we are going to have 1 0 at the input to this NOR gate, right? When we have 1 0, right, the output is going to be 0, right? So we're going to get a 0. Previously we had a 0, even this time we are getting a 0. So this is the final state of Q. So this 0 was fed previously, even now we are going to be feeding this 0 again, so this doesn't need to be fed once again. So this is our final state, right? So what we are going to say is that the final state of Q is 0, and the final state of Q bar is 1, right? Okay, this time the initial state of Q is 0, and the initial state of Q bar is 1, and the inputs are R equals 0, R equals 0, and S equals 1. So S is 1. Okay, let's see what happens now. This 0 which is at the output is going to be fed back, right? So we have 0 1 here at this input, which will give us a 0 at the output. So we'll get a 0 here. Previously this state was 1, right? This time it is 0. So this 0 is going to be fed back, right? So now we have 0 0 at the input. When we have 0 0 at the input, we get 1 as the output. So this time we're getting a 1 here. Okay, previously the state of Q was 0, but this time the state of Q has changed to 1. Since the state of Q has changed to 1, this new state needs to be fed back. So we're going to feed this new state of Q back to this NOR gate, and this is going to become 1, right? So when we feed 1 1 at the input, we get 0 at the output, right? Previously we had a 0, and even the new state of Q is equal to 0. So we will just feed it one more time, and if we feed it one more time, we get a 0 here. When we give a 0 0 at the input, we are going to get a 1. So this new output is still going to be 1. So this basically means that this is our stable state, right? This Q is not changing now. So the value of Q is going to be 1, the final state of Q is going to be 1, and the final state of Q bar is going to be 0. Now let's try. Okay, so let's try this where the initial state of Q is 0 and Q bar is 1, right? So that's the initial state, and the input signal S equals 0. S equals 0, right? So this is 0. Let me rewrite that. So S equals 0 and R equals 1. So R equals 1. Okay, let's see what happens now. This is the initial state of Q, so this gets fed back here. So now we're going to have 0 0 here. 0 0 gives 1 as the output. Previously we had 1, even now we have 1. This 1 is being fed back here. So now we have 1 1. When we get 1 1 as input, the output is going to be 0. So previously we had 0, even now we have 0. Let's just give it one more shot. Let's just try it one more time. Okay, so we're going to once again give this 0, which is our latest state, right, as input. So once again we have 0 0 as input. Once again we are going to get 1 as output. This 1 is once again going to be fed back, and we're going to have 1 1 at the input, which is once again going to give a 0 at the output. So this state is final, right? This state is not changing. So the final state of Q is 0, right, and the final state of Q bar is 1. The SR flip-flops can also be implemented using NAND gates. So this solution that we have right now is based on NOR gates, but SR flip-flops can also be implemented using NAND gates. Now these circuits are also called sequential circuits because the output is being fed back, and this output will potentially change the next output. So there is always a possibility, because the output is being fed back as input, so the next output could change because of this output which is being fed as input. So this is an example of a sequential circuit. The other circuits that we've been doing in logic gates, which you did in A1, were examples of combinational circuits, but this is an example of a sequential circuit. And I hope now that you will be able to fill the truth table if you get one in the exam. Now these SR flip-flops are also used to store bits in memory. So these can be used in the RAM. Millions and millions of SR flip-flops can be used in the RAM. You should know that one flip-flop, one SR flip-flop like this, can only save 1 bit, and these can be used in the RAM. Millions and millions of these can be used in the RAM to store many more bits. One SR flip-flop circuit is only going to be able to store 1 bit. Okay, one final point that I forgot to mention was that this input, where S is 1 and R is 1, is not fed to this SR flip-flop. So this input is never fed to this flip-flop because this creates an unstable circuit. This creates an unstable circuit. So S is equal to 1 and R is equal to 1 is never fed to the SR flip-flop.